Hello and welcome to topic 1 for Center High Campus Science 10 Chemistry. My name is Mr. J, and today we're going to cover some safety information for the course. We're going to talk about WHMIS, and we'll talk a little bit about different forms of classification of matter. I apologize for my writing and if there's some quirks with the setup. We're getting used to recording in this way. WHMIS, it's an acronym. It stands for Workplace Hazardous Materials Information System. And it's not just the symbols that you're going to see here. It includes the symbols as well as labels that are put on products, safety data sheets, and some education for workers or students like yourself. The reason we talk about WHMIS is, well, first of all, it's useful to you. If you have a job right now, I'm certain that you have probably seen some of these symbols on materials around your workplace. But for a science course, we're going to head to the lab for this course, and there's a lot of different materials that we use in the lab that have innate hazards, and so it's important that we recognize what the symbols might mean on containers and how we should treat them. So what we see here first is some compressed gas. I had already written that from a previous recording. Compressed gases are any sort of container where we are going to force, as the name says, gas into the container, kind of redundant. Some examples of where you might see this. This is medical oxygen. So we've got a whole bunch of containers of compressed oxygen. You might see this in a hospital for patients that require pure oxygen. You might also see compressed gas on a construction workplace. If there is fuel for a torch, for example, that could be stored in that way. Containers with compressed gas should be treated with care. Definitely be careful in how you store them. Don't drop them, and keep them away from anything that might puncture the container and cause the gas to release very quickly. Many of these gases also are in this next category here. These are flammable materials. Let me change that pen real quick. Flammable materials are any sort of material that can catch fire easily and combust. Fuel sources are a great example of this. Again, thinking of a construction work site, gasoline. But within the lab, ethanol is a common solvent that we'll use in several science labs, and that's a flammable material. We keep them away from flame, and we store them in special areas as well. This next category looks like the flammable symbol. It's got a similar sense to it. It's got the flame, except it's got this circle in the middle. You can think of this circle as an O, and that O stands for oxidizing. These are materials that add oxygen to a combustion reaction, and they're going to actually make a fire burn even hotter. They're also going to oxidize other materials, cause oxidation reactions, not necessarily a flame, but they can oxidize metal, causing rust, and that can cause damage in other ways as well. This next one here, these are explosive. This is often referred to as the explosive bomb symbol. These are materials that can cause a rapid explosion, expansion of gas. The next one here, this skull and crossbones, is part of a series of symbols that refer to the toxicity of different chemicals. These ones are immediately. If you see this one, this is immediately toxic. Any material that has this skull and crossbones is an immediately toxic. You're going to cause immediate effects by drinking this or ingesting it. Sometimes it can be absorbed through the skin or inhaled. This can be fatal very quickly, this skull and crossbones. We'll contrast that to this symbol here in a moment. This next symbol here, you'll notice, doesn't have the red diamond around it. This is the symbol for a biohazardous or an infectious material. something that has a high likelihood of causing some sort of disease or organic ailment. Anything that comes from the human body and has the potential to carry a virus or a bacteria or a pathogen of some other kind is probably going to be labeled in this. If you're interested in a career in healthcare, then any of these sort of materials here that you see on the screen, syringes especially, blood, bandages, those things will all be labeled biohazardous. Something in a sharps container, those are all biohazardous materials. This next category of materials here, these are corrosive, something that has this label. And corrosive materials, they are going to eat away at substances that they're poured on. If we zoom in here, this is not the best quality picture of the corrosive symbol, but we have two tubes. This one's being poured onto a metal surface or perhaps a wooden surface, and it's eating away at it. This is a person's hand. I know it's not the best quality picture right there. But often we think of corrosive as like, the hand goes into acid and it melts away the skin, very grotesque. But corrosive can also refer to substances that will eat away at important infrastructure. So this is a pipe that has been corroded. Materials that would speed up that corrosion would be in this category as well. Over here, this next symbol here, these are health hazards. These materials are also toxic. Oops, I spelled that. Hazardous, health hazards. These materials are also toxic, but unlike the skull and crossbones, the health hazard category does not have the immediate effect upon however the toxin enters the body, whether it's breathed or absorbed through the skin or ingested. But over a long period of time and several exposures, these things can be carcinogenic or they can cause other long-term health effects. You're often thinking, if you see this symbol, this is more long-term repeated exposure. This symbol here is more of a one-time thing. This next one is the exclamation mark symbol. That's the literal name for it. You can think of these as irritants. Irritants, something that's going to cause harm, but not to the same degree as, say, the skull and crossbones. For example, I saw this symbol on a bottle of hand sanitizer where that can irritate the skin, and if you leave it on the skin, if you don't rub it in, or if you use a lot of it, your skin's going to get dry, it's going to get irritated. Finally, this category here, let me just make sure that you can see it. These are our environmental hazards. So, environmental hazard. Environmental hazards, if they're introduced to the ecosystem, can cause serious harm to a variety of different organisms. So you have a picture here, again, not the best quality, but it's like a fish dying. An example of this would be like an oil spill, but lots of things can be environmental hazards. It's important to know how to dispose of wastes, especially in the lab scenario, because some of those, if you just dump them down the drain, it's going to go through the sewer system. Who knows exactly where it's going to end up? It can move through the food chain, and it can cause damage to the environment. So these are some symbols you're going to be tested on. It's important that you know what each of these mean. And on the next page, if you take a look, there's some practice questions. I'd encourage you at this point to pause the video, and if you haven't already, give a shot at trying to fill out these without looking at the rest of the video, but then I'll walk through them. So take a moment, pause the video, and try and fill out some of those practice questions for WHMIS. All right, first question, what does WHMIS stand for? WHMIS is an acronym for Workplace Hazardous Materials information system. A lot of what it is in the name. So a system for identifying the information about hazardous materials in the workplace. So if we're looking at these next questions here, the purpose of WHMIS is to provide information on using and storing workplace hazardous materials. I mean, it's in the name. Absolutely. That is a true statement. Maybe a highlighter looks a little bit cleaner there. This is a true statement. Storing workplace hazardous materials. Absolutely. You don't want to store some materials that might react with each other next to each other. And you also want to store them in areas where they're not going to spill or be accessed by people who shouldn't be accessing them. Also is going to tell you information on how to handle them. For example, if you're looking at the previous page and you see something that has this flammable symbol next to it, you're probably going to want to avoid bringing that material anywhere close to a flame. The following materials can be considered hazardous materials: paints, cleaning products, and solvents. Absolutely. These will all have WHMIS symbols associated with them. This word solvents, we'll come back to it, but a solvent is something that dissolves something else, and depending on what this chemical is, it could be pretty deadly. It could dissolve a lot of things. Some symbols you might find on the following. There's more than one right answer here. A propane tank, it's a fuel source, definitely flammable. Often stored as a compressed gas. Maybe even explosive. Multiple symbols you could find. The question does say what symbol, so I'm going to provide multiple though. The bottle of bleach, you'll probably find the toxic symbol, the immediately toxic symbol on there, so the skull and crossbones. Also a corrosive substance and an environmental hazard. Those are all good options. Car battery acid. Car battery acid, definitely going to be corrosive. Definitely going to be corrosive. It's got acid in the name. And, you know, there's lots of other options there. I'm just going to stick for one for each of these. Nail polish remover. A lot of nail polish remover is based on a chemical called acetone. You don't need to know that, but acetone does happen to be flammable. But you could also have health hazard on here for long-term exposure, and you could definitely have the irritant exclamation mark symbol. Gasoline, absolutely flammable. A urine sample, anything that's coming from another human, we're going to label as biohazard. I've switched to purple here, and the reason why I have these all in red is that just helps me remember that all of these symbols have the red outline, except for biohazardous infectious, which has that circle outline on it. All right, join me. We're going to flip to the next page. We're going to talk about the classification of matter. As a real short overview of WHMIS, we didn't touch anything on safety data sheets or chemical labels, but we are focusing instead on the chemistry part of it. The symbols, those are important. Some symbols that you might likely see on different substances, those are questions that we might ask you about. Classification of matter. Everything in the universe falls into two general categories. There's matter and there is energy. So matter is everything but energy. The general definition for matter is that matter is anything that has mass and takes up space. So I'm made of matter, you're made of matter, water is made of matter, the air around me is made of matter. Matter has three general states. We've got your three states of matter. You're going to find matter in solid, liquid, and gas form. Matter is the big overarching theme here. From there, we can go to some more specific categories. We'll break down matter into either being a pure substance or a mixture. A pure substance is made of only one type of particle. So if you were going to zoom down to the very small, very, very microscopic level, everything within a pure substance looks the same. It's either going to be an element or it's going to be a compound. And all parts of a pure substance are identical. Here's our two categories of pure substances right here. We have elements and we have compounds. So we can put those in those blocks here. We've got elements and we have compounds. Elements are composed of one kind of atom. In a later lesson, we're going to be looking at the periodic table of elements. So anything that you see on the periodic table is an element. And you can think of an element as kind of like a flavor of atoms. We can't break these down chemically into smaller substances. Sometimes they exist in pairs. Examples of elements, you could have iron is an element. It's on the periodic table. Its symbol is Fe. But oxygen is also an element. Its symbol is O, even when it exists as O2. That's a little bit ahead of ourselves, but later on in this unit, you're going to see some elements like to exist with multiple atoms together. They're still an element because they only have one kind of atom. So if I am looking at a beaker here, let's imagine, you could welcome to draw this picture as well. I am looking at a beaker, and inside my beaker I have one type of atom. This is an example of a pure substance. This beaker is full only of these blue atoms. Only one type of atom. These are elements. Compounds are composed of two or more kinds of atoms in a certain ratio. And I should add here, they are chemically combined. Chemically combined. You've probably seen some compounds before. Example of a compound would be water. H2O is a compound. We've got a specific ratio of 2 hydrogens for every oxygen, and they are chemically combined together. You might have seen NaCl, that's sodium chloride, that's table salt. These are compounds. They are chemically combined. If I go back to my beaker example here, let's draw a beaker that's going to represent a compound. We'll make this water. We'll make this an oxygen, and it's got some hydrogens attached to it. This is an oxygen, and it's got some hydrogens attached to it. The oxygens are getting progressively bigger, but that's just my drawing. If you're taking a look here, there's only one type of particle inside this beaker, so it's still a pure substance because these are all different examples of the same particle, even though every particle has more than one atom in it. So every particle is identical, meaning it's a pure substance. If you look in this beaker, we just have a red circle with 2 blue dots. But there's more than one color of atom, which means it's a compound. So this is a good example of an element, and this is an example of a compound. On the other side of this organizer here, we have mixtures. Mixtures contain more than one type of particle, so they're going to have more than one type of element, more than one type of compound. We've got homogeneous mixtures, and we have heterogeneous mixtures. Homogeneous and heterogeneous. Missed an O in heterogeneous. There we go. Just sneak that in there. Homo, this prefix means the same, so everything in here is going to look like one thing. Hetero means other or different. Mixtures that contain different components but appears as one thing. These substances are distributed evenly among one another. An example of a homogeneous mixture would be salt water. If you're looking at a glass, or honestly tap water also counts. Tap water is not pure water. You've got salts dissolved in there. You've got calcium and other things dissolved in the water, but it all looks like one thing. Everything inside that looks like one thing. You can also have solid homogeneous mixtures. For example, if you are looking at a piece of steel, that is a alloy. It's a mixture of different things. It's iron, but it also has some carbon, and if it's stainless steel, probably some chromium, all mixed together, but it looks like one piece of metal. If I'm looking at your, I don't know if I can get this to zoom in really well, but let's see. Oops, that's the wrong camera. All right, if you are looking really close at this little piece of metal, this is a little end of a cable. It's a little blurry on the camera, that's okay. It all looks like one shiny piece of metal. That's the takeaway there. It all looks like one shiny piece of metal, but it's a mixture, even though it looks like one thing. It's got not just iron in it. Mixtures that you can see have different things, those are heterogeneous mixtures. So, for example, here I have, we'll go back to that camera, see if that looks what I want it to look like. Right here, I've got a box of Tic Tacs. You could claim this whole thing is a mixture, the box and the Tic Tacs. You can see the clear difference between the box and the Tic Tacs. You could actually say that maybe the Tic Tacs are almost a homogeneous mixture. It looks like one thing, but you can read the ingredients on the back and they look like one solid yellow thing, but they're in fact made of several different substances, all mixed together. So, once again, homogeneous appears as one thing. Salt water is an example. I'll put stainless steel here. I think that's a good example. Doesn't have to be a solution. Heterogeneous mixtures, you can tell that there are different parts to it. They appear separately. If you've got a cup of water and you put some sand in it, you can tell there's different parts. So we're going to say if you mixed oil in water or dirt in water, all right. On the next page here, I would invite you to take a look at this chart and try and classify these mixtures as homogeneous or heterogeneous. Remember, homogeneous looks like one thing, and heterogeneous, you can see different parts. Pause the video now. Try it. Take a look at the answers on Google Classroom. You'll have you compare your answers there. And that's it for this first lesson. All right. Excellent.